Hey there, Mr. Loma here again. I thought I would do one of the hard Iroc questions for you. And basically, what those mean are that you couldn't just use the power rule. You had to use something else because the power rule wouldn't work. And in other words, it couldn't be written as something x to the something. So, for example, if I asked you to find Iroc to y equals x plus 3 over x minus 2 at x equal to 3. So we're talking about a function here. It has an asymptote at x equal to 2 from advanced functions, and we want to know what the slope of the tangent is, or the Iroc to this at x equal to 3. And so we can't just use the power rule because the bottom is not just a single monomial. So we're going to do this the hard way. Well, what's the hard way? Which is why this is called the hard Iroc. M tan, we have to go back to our basic definition of the derivative from first principles, which is f of x plus h minus f of x all over h. And then now we just put in our function. And as we've seen in class, it's always a good idea to put the original function in first. So this one is going to look just like that function, except everywhere where there's an x, it now turns into x plus h. Now this looks gross already because we have a double-decker fraction. So what we're going to do is right off the bat, and I'm going to save some time here, I'm going to put the 1 over h at the very end. And then we're going to get a common denominator with the other two terms. So I actually am not going to skip a step here. I was going to, but we will just do this. I'll make sure I have enough room. Okay. Guess we can leave that right there for now. And then what we're going to do next is we're going to get our common denominator, like I said. So the denominator we're going to need is x plus h minus 2 times x minus h. So we're going to need a bit of room, especially on the next line. So for the first term, we had an x plus h plus 3. And on the bottom, we multiplied by x minus 2. So we do the same thing on the top. And for this term, the second term over here, we had an x plus 3 on the top. And we multiplied the bottom by x plus h minus 2. So that's what we're going to do on the top as well. And we can't forget there's a bracket here. And we need to put our 1 over h in there too. Okay, so what do we got here? Let's see, hopefully that's not too small. I'm going to shrink it a little bit more here, give some room. Okay, so this is going to be quite a big line here. We're going to have limit h approaches 0. And just so that I don't forget, I'm actually going to, I don't think I'm going to have enough room. I'll have to write really small. I'm going to tuck the h in underneath here. And just a note, we talked about this in class, but this h, all it really is sitting there doing is waiting to be slashed out. He doesn't have a very happy life because really he's just waiting for at some point this big expression to not be 0 over 0. And in order to do that, he's waiting for an h to appear on top so he can just be slashed out. Okay, so now we have to expand two sets of giant brackets here. So step one, we got to keep track. There's going to be 12 terms altogether. So what we're doing here is we're expanding this bracket into that one and then this one into that one. This negative sign, I'm going to highlight it like I did last time here. This negative sign has to apply to everything in that second bracket. So watch out. That's where everyone makes a mistake. Okay, so what we're going to get is x times x, which is x squared, and then x times 2, which is negative 2x, then h times x, and then h times -2, and then 3 times x, and then 3 times -2, so -6. And on this one, this is the one we have to be careful about. X times x is x squared, but it's negative. X times h is xh, but it's negative. X times 2 is -2, but it actually ends up being +2. 3 times x is 3x, but it also switches to -3x. 3 times h is 3h, so that becomes -3h. And then 3 times -2 is -6, which becomes +6. I'm going to change my pen color to red because I think we're going to have a lot of slashing here. X squared and x squared go. 6 and -6 go. Let's see here. We've got a 2x and a 3x and a 3x and a 2x. They all go together. And actually, we have some extra stuff this time. We have an hx positive and an xh negative. They go away. So all of that stuff reduces to the very nice -5h. Okay, so, and I think you can see here, as always, everything that was left over contained an h. So the top does have a factor of h, which we are now allowed to slice out, which means we are finally rid of the 0 over 0 problem. Just a reminder, that's called indeterminate. And once we do that, we can substitute h equal to 0 in and evaluate this limit. And so you get -5 over x plus 0 minus 2. Notice how the limb part disappears now. And x minus 2, which is -5. And that just simplifies to x minus 2 twice, so squared. And that is the Iroc, or the mtan, to our function at every point. We want to know what it is at x equal to 3. At x equals 3, the Iroc is, and all we have to do, since this is so powerful, we just substitute in the value there. And 3 take away 2 is just 1. So that means it's dropping by 5 at that moment. So if we were to draw a picture of this and draw a tangent at 3, we would find that the slope of the tangent is -5. And we could draw a picture if we want. Probably not worth it at this point. Anyways, I hope that helps you out, and we'll talk to you soon.